Hello, welcome back. In this segment, I want to show you how to solve an interesting Scottish private club puzzle. There's nothing specific about the nature of the puzzle. It's just a bunch of logical statements. We are trying to find a solution whether a member can be added to the club. The club has quite a few rules. As you can see, there are 6 rules here. Every non-Scottish member wears red socks. Every member wears a kilt or doesn't wear red socks and so on. Married members don't go out on Sunday. A member goes out on Sunday if and only if he is Scottish. Every member who wears a kilt is Scottish and married. Every Scottish member wears a kilt. So there are 6 rules. We wanted to show that these rules are so strict that no one can be accepted. So how do we go about showing that? We will first show this with the help of proposition logic. In the later segment, I will show you the same with predicate logic. So with proposition logic, I need to identify the variables. Okay. The variables are, somebody is Scottish or not Scottish. Somebody wears red socks is a Boolean variable or not wear. Somebody wearing kilt is a Boolean variable. Married or not is a Boolean variable. Going out on Sunday is a Boolean variable. So we identify all the Boolean variables just by going through the rules. And then we start encoding all the rules one by one. What is the first rule? Every non-Scottish member wears red socks. Every non-Scottish implies red socks. We're not modeling for all, every, there exists things like that in this example. We are just creating a bunch of Boolean variables. We are going to see whether Z3 can solve and come up with an assignment which will satisfy all the 6 rules. Okay. All the rules are pretty much modeled using the logic that we talked about, like implies, or, and so on. One particular rule that is worth to call out is number 4, right? A member goes out on Sunday if and only if he's Scottish. So it's both directions. So how do you do if and only if? You just put 2 equals. That's if and only if. All right. So you have all the rules encoded here, 6 rules. And then we can create a solver object, add all the rules, and then ask the SAT solver, can you find a solution so that we can figure out whether we can add a member to the club or not. Okay, no member can be accepted to the club. Okay, the rules are so strict that even if you try, by the way, there are 32 possibilities you can try, right? Because there are 5 variables. You can try to create a truth table and check whether you can make the entire statement to be true based on all the rules. Okay, there are 6 rules. Your truth table will have to satisfy all of the 6 rules. Meaning, if you have a truth table with 5 columns for Scottish, red socks, kilt, married, go out, Sunday, and the 6th column for under all the rules, the last column, you're looking whether is there a way for the last column to be true. It turned out there is no way you can make that to be true, assuming Z3 itself is bug-free. So it's interesting to just take a natural language description like this, right? And encode using basic proposition logic and let Z3 help us to find any assignment to satisfy the properties of the rules. In this case, no assignment is possible. That's what we can infer because it's saying here, no member can be accepted to the club. All right, that's basically it. In the later segment, I will show you how to use predicate logic to model the same problem. Thank you.